Students, just a minute. I'm streaming on live to YouTube also. So today, I hope, please confirm someone in the corner which number I have written. First, let me confirm which number I have written here. In the chat box, you confirm. I want to confirm that whether screen is visible to you or not. Can anyone tell me which number I have written? 23. Yes, very good. Dear students, set back now. Today, one day, again, I have changed the concept. So today's concept is, I'm going to discuss about permutations and combinations. Permutations and combinations we are discussing. Today and tomorrow, I'm going to discuss about permutations and combinations. And day after tomorrow, it is definite integrals, properties of definite integrals, applications of properties of definite integrals. So because yesterday we have discussed about indefinite integrals, so I thought today and tomorrow you practice some problems. Before starting indefinite integrals, you practice some more examples on indefinite and come with all the formulas, standard integrals, basic integrals. You prepare and come for this definite integrals. Now today, once again, here permutations and combinations, we have 3 marks, 3 questions you'll get, sometimes 4 also. But only one thing is, all of you see now this year syllabus, especially 2022 Kcet, binomial theorem is deleted. Binomial theorem is deleted. Binomial theorem is not there. And they have removed the derivations of NPR and the derivations of NCR only they have removed. Derivations of NPR and derivations of NCR, not formulas. Proof they have removed. So once again, you try to understand. Today's concept actually was, earlier it was permutations and combinations. Permutations and combinations. But this year, binomial theorem is, this topic is deleted. And also in the permutations and combinations, the derivations of NPR and NCR are also deleted. So no need to study binomial theorem this year. Okay. As you are aware, first year around about 30% of syllabus is reduced. Second year complete syllabus you have to prepare. Dear students, before going to start this is the material I have designed for you. Observe once clearly. Of course, I'll share it in the group afterwards. This is the complete. This much only do. Don't do anything. And my suggestion for all of you is permutations and combinations, memory based and technique based. Now only you prepare, and little bit revision is necessary for this. Easily you can solve 2 or 3 questions in this within stipulated time also. So here, permutations and combination, this is the entire notes already I have arranged. Of course, for you people, it may be visible very, very small. And this is material, study material, specially designed for you people. It is totally including problems, shortcuts, some of the generalized statements and assignments and classroom work. So this I will be uploading in the WhatsApp group. You can just take WhatsApp group and just join the WhatsApp group and solve these problems only. So now here, fundamental principle. First, in the permutations and the combinations, what is fundamental principle? So fundamental principle means, I think it will be, we are going for this way. Look at this. I'll go to explain this. Fundamental principle, in that there are two terms. You have to memory based only, you have to listen carefully. Number one, multiplication, and second one is addition. Multiplication and addition. So only these two we have in our system now. Multiplication and division. What it says, with example, I'll tell you one condition now. Suppose here it is, you think that it is in the place, any one place you can take here, and Hyderabad. Somewhere it is Hubli, and again Bangalore, and this is Mysore. So total your task is total work is traveling from Hyderabad to Mysore. First, but means what is the problem is, to reach Mysore, there is no other option. You have to go to first Hubli. From Hubli, it is Bangalore. From Bangalore to Mysore. So Hyderabad to Hubli, there are three roads are there to reach. Number one, first road, R1, road 1, and road 2, and road 3. There are three roads to reach Hyderabad to Hubli. But Hubli to Bangalore, there are only two roads to reach. There are two roads. So that is again road 1 and road 2. And Bangalore to Mysore, suppose again there are three roads. Bangalore to, that is again road 1 and road 2. See, the total work is starting your journey from Hyderabad to reach Mysore. Dear students, remember it. Here, if you understand basic fundamentals, definitely you can solve the question now. Fundamentals, if you don't understand, it's of no use. And easy question. There is why I have selected today this topic is minimum, at least you need some 3 days to read at least first year textbook and some different examples. Permutations and combinations doesn't require any background knowledge of mathematics. Fresh you can study, fresh you can understand, fresh you can solve problems also. Suppose if I take, if we discuss about triangle, to solve any problem on triangle, you need to have the knowledge of triangle from 6th standard to 12th standard. Similar triangles, congruent triangles, right angle triangles. So that means like this. So this permutations doesn't require any previous knowledge of mathematics. So example I told you, suppose you need to solve any problem on triangles. I think triangles first concept starts from 6th standard up to 12th standard. You need to remember all the concepts of triangle. That's the reason. Permutations and combinations, easily you can do that. Yes, students, it is, yeah, that I will give you later on. Later on, I will tell you. Just listen carefully. Listen. And my dear students, this much I can tell you, my study material is almost all, because as I am somehow connected to Andhra Pradesh, Andhra, Telangana, Maharashtra, and Karnataka. Most of my material is designed by referring all these 4 states syllabus or 4 states competitive exams. That's what my material, whatever I have given, I can give you assurance that 60% you may get the questions what I am going to solve or the type of the problems whichever I have solved. So listen carefully and go through this. So my dear students, the total task is starting from Hyderabad to Mysore. But person has to do it. First he has to reach Hubli. To reach first task number one is to reach Hubli. He has got 3 ways. Second task number 2. Task number 2 is he has to reach Bangalore. To reach Bangalore, he has got 2 ways. Task number 3, That is, he has to divide to reach from Bangalore to Mysore 2 ways. What it is, fundamental principle of counting, what it will say is that total work will be done by product of each work. 3 into 2 into 2, 6 into 12. That is, a man can reach to Mysore from Hyderabad by using 12 ways. What is the fundamental principle? I will tell you first definition. Look at it. I think you can read this question. If one operation can be done in m ways, listen carefully, and corresponding to each way of performing the first operation, the second operation can be performed in n ways, then the two operations together can be performed in m into n ways. This is called fundamental principle of counting in this multiple. Okay, next I'll go for one more question. Look at it. So here in this case, so once again, I'm going to give one more example. Look at here. This is one more example. So there is a hall. For that, 2 in doors are there. You can go 2 ways, and 3 exit doors are there. Look at here. All of you listen carefully. Try to understand this concept also. First, to understand the basic, because with concepts only you can solve many examples. So this is the hall, get in, this is exit. So inside A or B, and this is the exit C, door D, and door F. See, the total task of a boy, the total task of a man is to enter into the hall and exit in the hall. So first work is what? Work number 1, entering into the hall. You can do it by 2 ways. And again, once after entering in the hall, he has to go out. How many ways? Work number 2, second work is going out. 3 ways. Total work will be done by 6 ways. The fundamental principle, what it says, that number of ways of first work into number of ways of second work. The total number of ways of work is multiple of their number of ways of first work into second work. That is 6 ways. Like this, see, number 1, he may enter from A, get out of from C, 1 chance. He may enter from A, get out of from D, that is second chance, AD. He may enter from the door A and you get out from the F, that is equal to AF. Second, he may enter from the B, again get out from the C, that is BC. He may enter from the B and get out from D, that is BD. And he may enter from the B and get out from the BF. That is totally how many chances are there? 6 chances are there. Fundamental principle. Okay. Now, look at here, my dear students, but here 2 things. You need to understand 2 things what happened. See, your journey is to reach from Hyderabad to Mysore, right? Hyderabad to Mysore. My dear students, please try to understand. I'll be using most of my lecture will be English only. Why? Because it is on YouTube live. So some different state students also can be watching. So that's what I have given this one. If you have any doubts, you ask me individually. I will mute first. I will mute it. I will clarify your doubts in Kannada also. Okay, no problem. My dear students, suppose if a person delayed to reach Hubli, automatically delayed to Mysore also. That means the effect of first work is following on effect of last work, right? If the first work is delayed, definitely last work also will delay. That means its effect, first work effect is falling on last work. That means they are not mutually exclusive. Mutually exclusive. Mutually exclusive means one work should not affect the other work. If first work means first task is reaching Hubli, you have done around about 8 hours late reaching Hubli, then definitely reaching Mysore also definitely more than 8 hours sometimes. Because again, second task reaching Bangalore 1 hour late. Again from Bangalore to Mysore again half an hour late means total your journey, total your plan will be. That means the effect of one work. If the first work is affecting last work also, then such type of working is called not mutually exclusive. What is mutually exclusive? Mutually exclusive means the first work and second work, any other previous work will not affect the further work. That is called, like, sir, what is that mutually exclusive? Look at this. I'll give you one example, you'll come to know. There are some numbers 1 to 20, which are divisible by 5. Your duty is to collect the numbers divisible by 5 and divisible by 7. Divisible by 7. The third task is the two task. Say, while performing the task of divisible by 5, this will not affect on this. That's what this type of system is called mutually exclusive. See, in task in the 1 to 20 numbers, what is your total work I have given? The total work is you have to collect the numbers from 1 to 20, which are divisible by 5 and which are divisible by 7. So when you are doing divisible by 5, this work will not affect this work. And this work also will not affect this work because totally interdependent. That's what this type of work is going to be called as mutually exclusive. So again, I'll go for mutually exclusive means definition. You see that clearly I've written here. Look at, read the question now once again. Statements only. If an operation can be performed in m different ways, one operation I've did it in m ways, and if another operation can be performed in n different ways, and the two operations are mutually exclusive. Clearly I've written what is mutually exclusive. Two operations are said to be mutually exclusive if the performance of one does not affect the performance of other. But in the previous example, first performance is reaching to Hubli. There itself you have delayed. Automatically that work will definitely delay. That is very simple. If you have very late breakfast, definitely that affects your timing of lunch. Then definitely it will affect on dinner also. Mutually exclusive means, once again try to understand, two operations are said to be mutually exclusive if the performance of one does not affect the performance of other. Very simple. When you have morning proper time breakfast, it will not disturb lunch also. This effect of breakfast definitely never disturb the lunch also. Why? Suppose if you delayed breakfast itself is 2 hours, then definitely this operation on breakfast definitely affects on lunch. Again, lunch further it will affect on snacks. Snacks will further affect on dinner. Mutually perfect. Then either of the two operations can be performed in m plus n ways. This is entrance point if you remember it. Here m into n, multiplication. Here addition, m plus n ways. I've given one example. Look at here. If a die, look at one small example. If a die is cast and then a coin is tossed, find the number of possible outcomes. See, when the die is cast, how many chances are there to get display? 6 possibilities are there, because it may be 1, die may fall on 1, fall on 2, so it may show 3, it may show 4, 5. And if the coin is tossed, look at, if the coin is tossed, the possibilities are what? It may fall head or tail, 2. The first operation is done by 6, second operation is done by 2. The fundamental principle says that multiplication 12 ways. The answer is B. Same case. Look at it. This is the one question I told you. How many ways can you choose a number from 1 to 20, which is multiples of 5 or 7? Multiples are divisible by 5 or 7. 1 to 20. First, divisible by 5 I'll take. So divisible by 5. Look at, when I'm divisible by 5, when I'm searching for divisible by 5, this work will not affect when I'm searching for divisible by 7. That time you have to add, not to multiply. Please remember, divisible by 5, what? 1 to 20, no? 1 means first number will be 5, second number will be 10, next number will be 15, next number will be 20. That is how many chances? 1, 2, 3, 4 chances are there. When you go for divisible by 7, divisible by 7, divisible by 7, how much? 1 means first number is 7, second number is 14, that is 2. First operation is done in 4 ways, second operation is done in 2 ways, you have to add. Why you have to add? Because when I am performing the operation of divisible by 5, it is not affecting divisible by 7 operation. That time you have to add. Therefore, 4 plus 2 is equal to 6 ways. The option A is the right option. Okay, got the idea? Now, look at this one more example now. I'm going to solve. If first factorial notation, once again, I'll give you introduction, then you'll go for it. First, you see that. Always 0 factorial or factorial 0 is equal to 1. My dear students, listen carefully. And what is 4 factorial? Immediately I'll tell you. Or 4 factorial or factorial 4. 4 means start from 4 and reduce up to 1. That's all. Into 3, into 2, into 1. 4 factorial means start from 4 and reach up to 1 in the reverse direction. What is 5 factorial? 5 factorial is equal to 5 into 4 into 3 into 2 into 1, like this. But one thing you can observe this. Can you tell me now what is 6 factorial? So what is 6 factorial? Or factorial 6 or 6 factorial? 6 into 5 into 4 into 3 into 2 into 1. But remember it here. 6 into, look at it. 5 into 4 into 3 into 2 into 1. We can write 5 factorial. That means always remember 6 factorial can be written as 6 into next number factorial. That means similarly, n factorial can be written as n into n minus 1 factorial. Look at here. 6 factorial, how am I written? 6 into next number factorial. N factorial is equal to n minus 1 into n, this n into n minus 1 factorial. So this is the definition of factorial notations. Now, my dear students, look at this example. If 1 by 8 factorial plus 1 by 9 factorial is equal to x by 10 factorial, we have to find out the value of x. Says 8, 9, 10. The smallest number is 8 factorial. What I'll do, look at this. 1 by, look at this, how to solve this question now. I hope, I think very cool you can study this. I've arranged a wonderful concept for you. 1 by 8 factorial plus 1 by 9 into 8 factorial we can write is equal to x upon 10 into 9 into 8 factorial you can write. I think you got the point. So 8 factorial we can write. But here, if I take 1 by 8 factorial common factor here, then what happened? That is equal to 1 plus 1 by 9 is equal to, here also 1 by 8 factorial into x upon 9, 0, 10 into 9. 1 by 8 factorial get cancelled. 9 plus 1, 10 by 9. 10 by 9 is equal to x by 9 into 10 we can write. 9, 9 get cancelled. X is equal to 100. X is equal to 100. I think option C is the right option. Option C is the right option. I think you are understanding this concept. Please try to understand. So once again, I'll tell you, if the first work is done by m base, second work is done by n base, the total work will be done by m into n base when they are not mutually exclusive. When it is mutually exclusive, definitely it will be m plus n. It will be m plus n. What is mutually exclusive? If one operation does not affect the other operation. The operation of breakfast, if it delayed, definitely it will affect lunch. That is called not mutually exclusive. If you have right time breakfast, automatically it will not affect the lunch also. That is called mutually exclusive. So this is the definition I've already given you. This definition already I've given you. In this case, you need to understand the definitions of mutually exclusive. So last and final, once again, I'll read. This is the two definitions you need to understand. My dear students, now I'll solve some problems. Directly I'll go for. Next, I'll discuss about one more concept is permutations. Permutations. Memory based, only if you have good memory, and the combinations. Today I'll solve permutations, then we'll go for combinations. After that, day after tomorrow, I'm going to discuss about definite integrals. I'm going to discuss about definite integrals. Look at it. Permutations. Simple way you arrange, just Permutation means arrangement. Permutation means arrangement. Combination means selection. Selection. So in arrangement, order is important here. Order is important. But in the selection, order doesn't matter. Order doesn't matter. Order doesn't matter. Why? I'll tell you one example. See, why order is not a. Suppose in a restaurant or in any ice cream parlor, you have ordered fruit salad. Fruit salad. So only you want to have fruit salad. In that grapes are there, banana is there, apple is there, orange is there, or some other fruit like orange, like grapes, banana, apple, so on. Will you see that only we want fruit salad? Do you think that you will put only first grapes, afterwards you will put banana, afterwards apple? No, order is not required. Order is not required. Only we want fruit salad. At the time of making, there is no order. Order is not necessary. Whether you may put grapes first, afterwards apple, afterwards banana, afterwards orange, afterwards ice cream. How you put, finally it is fruit salad. But order, arrangement means order is compulsory. Correct? You will purchase some 12 to 13, 12 varieties of vegetables and green leaves. You all dump in the bag at the market. But when you come home, definitely in the fridge, systematically you arrange. Definitely. Systematically means first where you keep in the fridge is not a material. Suppose here vegetable bags are there. You will put all mirchi in one bag. Green leaf vegetables one bag. Brinjal is one bag. So systematical arrangement is compulsory in the permutations. In the combinations, only selections, order doesn't matter. So for that case, once again, I will give you this definition. Just once you read, I think you can understand here. Look at here. I've written this in this place. All of you observe this. Permutations concerns selection as well as arrangement. Correct? Vegetable purchase ಮಾಡ್ತೀವಿ. Vegetable purchase ಮಾಡಿದ್ರೇನು selection ಮಾಡ್ತೀವಿ. Arrangement ಮಾಡ್ತೀವಿ. Bag ನಲ್ಲಿ first ಯಾರು ಟೊಮೊಟೊ ಹಾಕಲ್ಲ. Nobody will put tomato in the bag because next so many vegetables you have to purchase. Order is essential. Concerns only selection. Combination means concerns only selection. Order of the selected item is immaterial. So this is one nature we have to go for it. So now in the permutations and the combinations, what we need to study, what all we need to study. You know what is the meaning of this one? Look at first, try to understand. I'll write 5P2 because 5P2 means total available objects here. These are available and arrangement. So out of 5, you have to arrange it to permutate 2. This is correct. Is it correct? 5P7. You can ask me one question. Common sense. Sir, how come it is 5P7 is possible? This is total books are only 5. How can I arrange 7 books? Totally we have only 5 books. Out of 5 books, how can I arrange? That means this bottom number should be less than or maybe equal to top number. That is 5. So NPR, what is the meaning of NPR? Out of n objects, we have to arrange, we have to arrange r objects at a time. NPR. Out of n objects, you have to arrange r objects. But here, what is r? Out of NP0. Yes, out of n objects, I am not arranging anything. That is r may be equal to 0. R must be less than or equal to n. Okay, this is it correct? Can anybody tell me now? I am going to write the example. 8P 1.5. Is it correct? Now I'll tell you, it's not correct. Why? Both are integers only. Out of 8, look at it. Out of 8 people, out of 8 students, how can I arrange 1.5 student? Either students can be 1 or 2, or you don't take any student. So that's what in NPR, once again, try to understand. Only, my dear students, again and again, I'm telling you, your memory plays an important role here, because you don't have much time to work. You don't have much time to work. And I know till already 12 days are over. You are still hanging around second PUC, first PUC, and so far you are not touching. You people don't know the damage what it will make first PUC syllabus. So therefore, N and R should be positive integers. Positive integers only, they cannot be negative also. That is what NPR. This is the one thing it is. So you know, aware of this one. Now look at here. So how it can be, next remaining things can be done here. Look at it, NPR. So NPR, there are two formulas. Start from N, reduce the numbers. N into N minus 1, into N minus 2, into N minus 3, into N minus R plus 1. One formula. Or NPR is equal to top factorial divided by top minus bottom factorial. Just recall these formulas. Don't think that there are two formulas. NPR is the only one formula. This way I can remember. Dear friends, NPR formula, there is only one formula we have. So here you see that. Look at NPR is equal to, the formula is N into N minus 1 into N minus 2, N minus 3 up to N minus R plus 1. Or NPR is equal to N factorial, or simply top factorial divided by top minus bottom factorial. Only difference is, no, what is this? The formula is same. Dear students, understand this. This is called open umbrella. This is closed umbrella. That's all. Usually when you take umbrella inside the home, we close. This is expanded umbrella, open umbrella. That's all. Both are same only. We never keep umbrella open in the house. It will be closed only because it consumes less space and it is easy to carry. That's all. So finally, what is the formula you are discussing now? What is the formula? Finally, I'll give you the systematic formula. NPR out of N objects, arranging R objects, taking R objects and arranging at a time. The formula clearly I'll tell you. N into N minus 1 into N minus 2 into N minus 3 into dash dash up to N minus R plus 1. Or this is open umbrella. If I close this umbrella, it looks like this. NPR is equal to N factorial upon top factorial upon top minus bottom factorial. This formula. Okay. And what is R here? Where 0 less than R is less than N. And here R and N R belongs to integers only, positive integers. That is R is greater than R is equal to 0 or greater than 0, but less than N. Or less than or equal to N also. Yes, of course, 10P10. Out of 10 books, I can arrange all 10 books at 10P10 is possible. There are 7 books. I can arrange all 7 books at a time. Therefore, 0 is less than or equal to R, R is less than or equal to N. So this way we can look at, on this basis, some examples I'll tell you. And one more NPR. What is, look at here. General meaning now. General meaning of this. Suppose, look at here. 10P3. 10P3. So the other meaning of 10P3 is taking 10 objects in your hand and filling up 3 places. 10P3, yes. Just we'll come to know this. I'll be giving the idea. Just wait. 10P3. Just remember it. 10P3 general English meaning. 10P3 means filling up 3 places. Filling up 3 places. 3 places. That means you can think like this. There are 10 students standing in the queue. There are 3 places empty. Out of 10, you fill up the 3 places. This is the general meaning. Similarly, what is NPR? Filling up how many places? Filling up R places. Filling up R places by taking n objects. So this way you can understand. So from this, I'm going to solve small examples, simple examples. So once again, NPR formula, all of you see that top factorial divided by top minus bottom factorial. This all you should remember, NP0. Out of n objects, I'm not arranging any objects. Therefore, top factorial divided by top minus n minus 0 factorial is n factorial, get cancelled. 1. You have to remember this. NP0, when the arrangements are 0, answer is 1. Sometimes NPN they'll take. NPN means out of n, that is equal to formula top factorial divided by n minus n factorial. We know that NPN is equal to n factorial divided by 0 factorial. As we know that 0 factorial is 1, NPN is equal to n factorial. So NPN is equal to n factorial. Please try to understand this formula. This much first you remember. NP1, what is NP1? NP1. So formula is top factorial divided by top minus n minus 1 factorial. Dear students, I taught you just n factorial can be written as n into n minus 1 factorial divided by n minus 1 factorial. N minus 1 get cancelled. So therefore, NP1 is equal to n. NP1 is equal to n. NP1 is equal to n. So this way you can understand. These are the simple terms where we need to go for small examples now. Look at. So some problems I'm going to start now. Here in this case, how these problems will be discussed, some of the problems. So some statements I've written here. Look at, these all you have to memorize. Number of ways in which n books can be placed on a shelf when two particular books are never together. So suppose I'll tell you one example. Totally 8 books are there. 8 books. 8 books in that when two particular books are never together. Look at this statement. Like example, in the books English and Kannada. Out of 8 books, when two particular books are never together. These 8 books, however you arrange in the shelf, English and Kannada textbooks should not be together. That time the formula to find out is the total books minus 2 into total books minus 1 factorial. This is the formula you have to remember. Read the statement. If at all you want, you can take a screenshot. Number of ways in which n books can be placed on a shelf when two particular books are never together. The formula is n minus 2 into n minus 1 factorial. Okay, that is one concept. Look at this. Here, the problem is already I've solved, but once again, I'll solve for you. Okay, look at it. Now, here afterwards, I'll go for direct method. Look at it. The problem is, I think you can see this problem. MP3 is equal to 210, then n is equal to. Look at, my dear students, n is equal to, first option is directly ruled out. Why? Can anybody tell me? Don't need to check first option. Why? Because n cannot be 1p3 is not possible, right? And n number of objects cannot be negative also. Minus 1p3 also not possible. How come? Minus 1 books, no problem. That is, and we have to see that in the place of n you put 7 and try, or 4 you put and try. I think better we'll put 7 first here, whether you get 210 or not. 7p3 will true. Okay, I have taken in the place of n, I have taken 7. 7p3, 7 factorial divided by 7 minus 3 factorial. Correct formula? Yes, top factorial. 7 factorial can be written like this: 7 into 6 into 5 into 4 factorial we can write. Therefore, 7 minus 3 is again 4 factorial. 4 factorial get cancelled. 5, 6 are 30, 37, the 210. Yes, correct. Answer matching this. That is, if I take n is equal to, look at here. If I take n is equal to 7, definitely the result will be 210. Therefore, The option is 7. That is the option C is the right option. Here afterwards, I'll give you a shortcut now. Look at it. 6P2. No need to apply formula. 6. Go for 5. So bottom number 2 means there must be only 2 factors. Bottom number 2 means there must be 2 factors. Suppose 7P4. Come on, tell me what you can write. 7. 4 factors. You have to see that only 4 factors you have to write. 7, 6, 5, and 4. Totally 4 factors. 1, 2, 3, 4 factors. Suppose 8P5. There must be 5 factors, right? 8. Come on, reduce it. Number 7. Go down. That is continuously you have to reduce. 8, 7, 6, 5, 4. 1, 2, 3, 4, 5 factors. That's all. From 8 you start, continuously reduce one number. And after finally, if you check, yeah, here it is what happened. 8, 7, 6, 5, 4. If bottom number is 5, there must be 5 factors. And this is the permutations you can go for. So that's what here afterwards, no need to see. This formula is difficult. Suppose if I have given, look at here. If the problem is like this, suppose 200 P45. It's very, very difficult. 200 factorial divided by 200 minus 45 factorial. So don't use this formula. Better I'll tell you last and final 15P3. Are we right? Start from 15, go negative, reduce number 14 into 30. That's all, because 3 means 3 factors. And 25P4. What you can write? Start from 25, 24, 23, 22. Finally, 4 factors. 1, 2, 3, 4 factors. I think you understand this question. Then I'll go for next example. Look at here. How many ways? Now the basic questions becomes harder. Really, why I'm teaching this topic here? Permutations, combinations. It will sharpen your logic. It will sharpen your intelligence. It will refresh also. How many ways can 7 people be seated in a row for a photograph if 2 particular people always want to be together? Read the question carefully. How many ways can 7 people be seated? Can 7 people be seated in a row for a photograph if 2 particular people always want to be together? Okay, I'll tell you one thing. People 2 and people 3, they want to be together always. If 2 particular people always want to be together, that means P2, P3, they are together wherever they go. And afterwards, P1, P2, P3, P2 is there already. That's P4, P5, P6, P7. Or else we'll do one thing. These people want to be one together means we'll bundle them, we'll pack them in one box. Then how many are there? 1, 2, 3, 4, 5 plus this box. In this box, there are 2 people. Are you getting this point? So 1, 2, 3, 4, 5. This entire box is one box. 6 people. How many ways we can? Totally 6 are there. We have to arrange total 6. First work is done by 6. That is equal to 6 factorial. And inside the box, these 2 people can be arranged in 2 ways, right or not? P2 first, P3 second. Otherwise, P3 first, P2 second. That is 2 ways into 2 factorial. First factorial into 2 factorial. That is equal to 6 factorial into 2 factorial. 6 factorial is 6 into 5 into 4 into 3 into 2 into 1 into 2 factorial 2 into 1. So can anybody calculate and tell me immediately? If you have calculated, you have to tell me. How many ways? What is the answer? 6 5s are 30, 30 4s are 120, 120 3s are 360, 360 2s are 720, 720 2s are 200, 2 2s are 4, 1440. I think option A is the right option. Option A is the right option. So once again, try to understand this question. Once again, I'll explain. Please look at two people want to be always together. Two people want to be always together. They don't want to go anywhere. That's what we'll put two people in a box. Two people in a box. In a box, we'll pack it. People 1 and people 2. They are in the entire box. Wherever you go, this box has to be arranged. Along with this they want P3, P4, P5, P6, P7. Totally 7 people. That means this box is 1 unit. 1, 2, 3, 4, 5, 6 people. We are going to arrange all the people. No? Out of 6, we have to arrange all. First work is done by 6 P6. First work is, that is 6 factorial. Next, inside the box, we can arrange these people. P1 will be in first place or P2 will be in second place. Otherwise, P2 will be in first place and P1 will be in first. This is 2 ways. So we can arrange inside the box 2 ways. So therefore, first work is done by 6 ways. Second work is done by 2 ways. Therefore, total work will be done by 6 factorial into 2 factorial ways. That is, out of 2, we have to arrange 2. That is equal to 2 factorial. Just now I taught you, NPN is what? N factorial. In that way, we can solve this question. Okay, look at next question now. We'll go. So here, again, this question is also most important. I will enlarge this question, don't worry, so that you can see this. Systematically, you can see this question now. I think it takes some time for you to understand this question. So how this can be arranged? Look at this question. I think you cannot see this. I will just make it clear now. Now you can read this question properly. Look at it. First, sometimes some students may get confused because an entrance, how to identify the question based on permutation and combination. Number 1, selection stands for combination. Selection or groups, combination. Arrangement comes on permutation. This much first you remember. How many ways? 7 maths books, 8 English books, and 4 Kannada books can be arranged in a shelf if the maths books are always together. Maths books are always together. Once again, I read the question for you. How many ways? How many ways? Look at this. How many ways can 7 maths books, 8 English books, and 4 Kannada books can be arranged in a shelf if the maths books are always together? So maths books means 7 maths books are there. Look at here. All of you see this? Once again, M1, M2, M3, M4, M5, M6, M7. This in the shelf, all 7 maths books should be together means we'll bundle it now. We'll bind, yes, we'll pack this. We'll pack. That is, wherever this bundle we keep it. Along with that, how many books are there now? 8 English books, right? Along with that, 8 English books and 4 Kannada books. Total, how many books are there now? Now you consider this is 1 book only. Now this is this entire, this is pack. This package is 1 book. 8 plus 4, 12, 13 books are there. So now we are going to arrange out of 13 books, first work. 13 out of all 13 books you have to arrange. That is equal to 13 factorial, first work. Then inside the box, 7 books can be, all 7 books we have to arrange, 7P7. The second work is 7 out of, you have to arrange 7 factorial. The total is what? The total work will be done 13 factorial into 7 factorial. That is equal to 13 factorial into 7 factorial. Which answer is correct? Option A is the right option. First work is, look at here. All 7 books we are going to wrap. We consider this one is a 1 book. Along this 1 book, 8 books, 9 books, plus 4 Kannada books, 13 books. So that means first in the self means it is horizontal only. Out of 13 books, we have to arrange all 13 books. Here the package of all 7 books is considered as one book. That is first work is done by 13 P3, that is 13 factorial. Now we'll open the box. Inside the box, all 7 books can be arranged. All 7 books, totally 7 mathematics books are available. We can arrange all 7 in 7 factorial ways. The first task is done by 13 factorial. Second task is done by 7 factorial. The total number of works, total work will be done by their product ways. 13 factorial into 7 factorial ways. So that the right option is option E. Now, here once again, look at this now. Once again, page number 5. Only this memory based only you can work. Nothing can be done. Just memory based you need to work. So now once again, these are some problems advanced I've solved for you. Now, still once again, of course, this option you don't go. I am not sure that options are properly typed. Look at this question. Once again, I'll enlarge this question for you. Look at this. Option somehow he has given some options here. Read this question now. That leave the options now. You don't bother about the options. In how many ways can 9 boys and 6 girls be arranged in a row if no 2 girls are together? I think you're understanding this question properly. I hope you are understanding properly. Be cool. Be slow while doing algebra, because algebra makes dil gabra, or algebra is a mind cobra, people will say. So be slow whenever you're handling the permutations and combinations or any basic problem of algebra. In how many ways can 9 boys and 6 girls be arranged in a row if no 2 girls are together? First, look at my dear students. First, what I'll do, I'll arrange all 9 boys first in the row. First, I'll arrange all the 9 boys in a row. Okay, how many? All 9 people, correct or not? All 9 boys, that is out of all 9 people, out of all 9 I'm arranging. That is equal to 9 factorial. So 9 people, first task I've done. That is task 1 is completed by 9 factorial. That is, look at here. Boy 1, boy 2, boy 3, somewhere, any one of the operation, boy 3, boy 4, boy 5, boy 6, boy 7, boy 8, and boy 9. 6 girls, they are, see, arranged in a row. They all, boys and girls should be arranged in a row only. But 6 girls to be arranged, but no 2 girls are together. In the arrangement, no 2 girls sit together. Okay. Now look at here. How many places are there where the girls can be arranged? Number 1, the girl may sit here 1, or girl may sit here 1, or here, or here. See, look at this. Where the girl can sit. To sit girl, how many places are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 places are there. Out of 10 places, we have to arrange 6 girls. Are you getting this point? Look at this. Round circles. Girls, the round circles are the places where the girls can sit here. But how many places are available? How many places are available here? Clearly understand the question. There are 10 places here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 places. Out of 10 places, we have to arrange 6 girls. That is equal to, the first work is done by 9 ways, 9 factorial, and the second work is done by 10p6 space, then total work will be done by this is. So that means the answer is we can write 9 factorial into 10p6 is the final answer. Or you can write total answer afterwards. You can write total answer afterwards. I think this question is, I think I've cleared your question. Somebody answered this question. I don't know what way. 9 factorial into 5 factorial. I think it's not correct, my dear student. I think it's somewhere, you got the point. See that small example. How we got 10p6 now? How we got 10p6? Because to sit, girls to sit. But as per the condition, as per the given question, no two girls are together. Means two girls can never sit together. That means girl can sit here. One. First starting with the girl, again boy, girl, boy, girl, boy, girl, boy, like this. So first to see that how many places are available for the girls. There are 10 places. Out of 10, we have to arrange 6 girls. First work, boys I have arranged by using 9 factorial. Second work is 10p6. The total work will be done by 9 factorial into 10p6. I hope I've cleared your doubt. Next, I'll go for one more question now. Look at this is also very, very important question, my dear students. Circular permutations. First, let me enlarge this. Then we'll go for circular permutations, also very much important. I hope this I'll explain it in detail first. Check it out. Let me first enlarge this question. One by one I'll go. Look at here. This is the question now. So if you understand this question once again, first now only, the number of circular permutations of n things is n minus 1 factorial. You are not understanding this concept. Once again, I'll explain this. See, look at it. So here in this case, just a minute, give me 1 minute time. I will be just one. Dear friends, sorry for interruption once again. The number of circular permutations of n things is n minus 1 factorial. A simple question here only I will write so that it will be useful. Suppose 7 members are there. These all 7 members has to be arranged in a round table. They should be arranged, sit in a round circle, circular. This all 7 people means very simple. That's 7 minus 1 factorial. That's all. If 6 people to be arranged in a circular, in the circle, 6 minus 1 factorial you can write. If 10 people to be arranged in a circle, you can write 10 minus 1 factorial. Nothing can be done. I cannot explain all the things here. Now, the only thing is you have to understand. Now you can understand. The number of circular permutations of n things is n minus 1. The number of circular permutations of 25 people is 25 minus 1 factorial. But my dear students, here one more trouble. What is the trouble I'm going to tell you? Look here. What is the trouble? So the trouble is here. Look at here. What is the trouble? What is the confusion you will definitely face here? Number 1. So clearly, number 1, first you will tell you I've given 3 people. I will ask you to arrange them in a circular. Therefore, the answer is 3 minus 1 factorial you'll give. Correct? 3 minus 1 factorial. But here, my dear students, remember it, 3 people. Suppose example, here teacher, here madam, and here student. Teacher, madam, or principal, and madam, and student. Sure. That means if you go for clockwise, yes, clockwise, first principal, madam, and student. If you go for anti-clockwise, difference. The arrangement of principal, student, and madam it comes. That means definitely there is a difference in clockwise and anti-clockwise. There is a difference. So when there is a difference in clockwise and anti-clockwise, just a given number minus 1 factorial you do that. Once again, try to understand. If there is a difference, yes, there is a difference. Clockwise means the arrangement comes PMS. Anti-clockwise means it comes PSM. Different. PMS is different from PSM. So when the clockwise arrangement and anti-clockwise arrangement makes a difference, that time total objects minus 1 factorial. Suppose 10 members are there, 10 people. That means in that, like first comes president, secretary, president, next managing director, after that secretary, afterwards principal, afterwards coordinator, afterwards HOD, afterwards lecturer, afterwards student. So if you make them to sit round table, clockwise, if you go for clockwise and anti-clockwise makes a difference. If clockwise and anti-clockwise makes a difference, the total arrangements will be total number minus 1 factorial. You remember it. Are you getting this point? Okay, that is completed. Second thing is, my dear children, in the garland, or we are preparing, that is called flower 1, flower 2 in the garland, flower 3, flower 4, flower 5, flower 6. So here clockwise and anti-clockwise doesn't make any difference. Like example, ornaments, diamonds will be round, pearls. So when it is, remember it, when clockwise and anti-clockwise doesn't make any difference. Sir, all are flowers only, sir. What is there in the garland? Garland, if you go clockwise and anti-clockwise, doesn't make any difference. If clockwise and anti-clockwise doesn't make any difference means, then definitely 10 minus 1 factorial divided by, never forget to write divided by 2. I think you are clear, my dear children. If clockwise and anti-clockwise, yes, there is difference means just total objects minus 1 factorial. Sir, clockwise and anti-clockwise, there is no difference, sir. That time you have to write it divided by 2. Now I'll show you this question now. Look at here. Top. Once again, here, once again, I'll make it big, this thing. With this, you can understand. Definitely you can understand how we can, it will be. Look at it. Yeah. So hope so you can read this once again. Clearly understand. In circular permutations, clockwise and anti-clockwise makes no difference. Then the number of circular permutations of n things is what you have to write. Come on, tell me. n minus 1 factorial divided by 2. n minus 1 factorial divided by 2. Once again, I tell. So here what? Clockwise, anti-clockwise makes a difference. Here you can see the difference. We can see difference. We can see difference. When you see the difference, sir, yes, sir, president, teacher, student. If I go clockwise, president, student, teacher. If I go anti-clockwise, president, student, teacher. So definitely there is a difference. That time total object minus 1 factorial. So, sir, clockwise and anti-clockwise in the circle same, sir. Why? Because like an example, garland. In the garland, all the flowers are there. Can you identify the garland how he has prepared? Whether he has prepared, he has put all the flowers clockwise only? No, you can't identify like garland, ornaments, gold ornaments, diamond ornaments, pearl ornaments. Doesn't make any difference here. There is one small ring in the marriage hall. On this marriage ring, that is an iron ring, in that he has put all the flowers here. Can you identify clockwise and anti-clockwise? So it doesn't make it. When the clockwise and anti-clockwise doesn't make any difference, that time you have to divide it by 2. Yes, friends, now here there is one question. You'll come to understand. Once again, this question I'm going to enlarge for you. Look at it. Directly answers cannot be done here. All of you see it. I think you can read this question properly. Once again, see this. Yeah. Now can anybody tell me? In how many ways 10 different precious stones can be arranged? 10 different, then because there are different. See, look at here. 10 different pieces. First one, red. Different, they are different. Next one is blue. Next one is green. Here it is purple. So that means if you go red, blue, garland, this is comes. Yes, there is a difference. That time only you can write 10 minus 1 factorial. That is equal to answer is 9 factorial. Why? In how many ways can 10 different precious stones can be arranged? Can be arranged. Look at here, can be arranged. Please, 10 different means what? Red, blue, green, or red, purple, yes, light green. Anti-clockwise makes a difference. When the difference is there, just total number of objects minus 1 factorial. One question is completed. Okay. Now let me go through one more question now. Look at it. Total questions how best you can understand. On that basis, I will show you now. Okay. This is one more question. All of you see this? My dear students, observe this carefully. Really very interesting. Look at this question now. I'm going to make it big so that you can see clearly. Yeah. How many ways can 8 persons be seated at a round table? Yes, 8 persons means person 1, different person 2. Here the answer is simple. 8 minus 1 factorial. 8 minus 1 factorial only. So the answer is 8 minus 1 factorial. 8 minus 1 factorial, that is equal to 7 factorial. 7 factorial. Yes, options are here. Some options are there. Next, go for next question. Look at here. I'll be taking one more example here. Try to understand. Yes. Please see this question. I think you are all understanding properly. That's what you need to work. You need to work, otherwise there is no shortcut for this. 28, just look at it. Here the question is like this. How the question will be in this case? Yeah. Read the question. How many ways can 6 boys be arranged in a circle if 2 particular boys always want to be together? Read the question very carefully. Here also clockwise, anti-clockwise makes a difference, right? That means there is no need to write divided by 2. There is no need to write divided by 2. How many ways can 6 boys be arranged in a circle if 2 particular boys are always want to be sitting? Boy 1, look at it. What I'll do? Boy 1, boy 2, I will pack them. I'll put them in a box. Totally 6 boys, no? 6 boys. That is boy 3, boy 4, boy 5, boy 6. Totally, this box will be only one boy. 1, 2, 3, 4, 5. 7 boys to be arranged in the circular means 7 boys means totally 7 minus 1 factorial. 7 minus 1 means 6 factorial. First time. But inside the box, these 2 can be arranged what? Out of 2 boys, we have to arrange 2. That is 2 factorial. 2 factorial. Total work will be done by 6 factorial into 2 factorial. 6 factorial into 2 factorial, we will find out 6 factorial is 6 into 5 into 4 into 3 into 2 into 1. Into 1 into 2 into 1 again. 6 5s are 30, 3 34s are 120, 120, 3s are 360, 720, 720, 14, 40. So that is equal to, first, how many ways you can solve this? So 6 factorial is how much you can see. How many ways 2 particular boys always want to be together? So totally 6 boys. That is, sorry, 6 means what? 1, 2, 3, 4. 4 and 1. Sorry, this is wrong, no? 4 and 5 factorial. Correct or not? 5 minus 1 factorial. 1, 2, 3, 4 boys, and this box is 1 boy. 5 boys are there. So that is equal to 5 boys means 5 minus 1 factorial. That is equal to 4 factorial into 2, because inside these two, 4 factorial is 4 into 3 into 2 into 2. 4 is a 12, 12 4 is a 48. I think option C is the right option. Option C is the right option. Just listen carefully. Now, once again, sorry, it was, I thought 7, not 7. It's totally 6. In that 2 boys are always together means total it will become 5. 5 boys in the circular, 5 minus 1 factorial, 4 factorial. Inside the box, 2 boys can be arranged 2 factorial. Okay. Again, last one more question now. Look at this is one more question. This way I'm going to just show you. So this one, how we can understand this question. Look at it. Yeah. How many ways, hope so you can understand this question now. How many ways can 5 boys and 5 girls be arranged in a circle if no 2 girls are together? How many ways can 5 boys and 5 girls be arranged in a circle if no 2 girls are together? First circle, 5 boys means definitely how many ways I can arrange? First we have to arrange 5 boys. That is equal to 5 boys means, look at here, 5 minus 1 factorial. That is equal to first task is completed by 4 factorial. Okay. Now 5 boys is arranged in a circle. Please listen carefully. So here the 5 boys are arranged in a circle now. Anyway, boy 1, boy 2, boy 3, and boy 4 and boy 5. Now, how many places are there? No 2 girls are together. Then how many places are there to sit girls? From here you can start 1, 2, 3, 4, 5 places are there. Out of 5 places, we have to arrange all 5 girls. That is second task, 5p5. That is equal to 5 factorial. The first operation is done by 4 factorial. The second operation is done by 5 factorial. As per the fundamental principle, the total work will be done by 4 factorial into 5 factorial. I think here it is a first option is big. 4 factorial into 5 factorial. I hope we can understand. Once again, I'll revise this, my dear students. In a circular permutations, if you find there is a difference between clockwise and anti-clockwise, that time total objects minus 1 factorial. If there is no difference between clockwise and anti-clockwise like garland, gold ornaments, that time total objects minus 1 factorial divided by 2. Never forget this one. I think, my dear students, I think you have understood. Please, I want to know your response in the chat box, whether have you followed this lecture or not. Just give me your response immediately in the chat box. It is also available in the YouTube now today. You can later on you can watch it if you have any doubts. So please, I want your feedback in the chat box. How you felt about today's class? Whether you have enjoyed, you have any doubts in that? Please let me know. Please let me know immediately, because as this live class is on recording, therefore I think hope so you can understand this. Yeah, thank you, Vishnu. Anybody else? Anybody else wanted to comment on this? Vishnu, thank you. And any other, if you have any other this thing, you can give me. Anyway, my dear students, thank you. Tomorrow also, again, once again, I'm going to tell you, tomorrow also I'm going to continue these permutations and combinations. Day after tomorrow, definite integrals. Hope so you can see the timings and course will be uploading. Hope so you attend this. So as this material, study material, I will upload to you people. In WhatsApp group, I will post it. You can just study them. At least you solve minimum those examples so that you get some general idea to tackle permutation and combination problems. Thank you. Thank you, my dear friends. Thank you.